The second question says, what is the probability that XY fall in the region A? That is to say, probability of XY is an element of A where A is the event such that X plus Y is less than or equal to 1. Remember, X is the number of blue balls, whereas Y is the number of what? Of red balls. So the event A is that the sum of the red balls and the blue balls should not be more than 1. So the possible ways that this condition is true is when X is 0 and Y is 0, or X is 0 and Y is 1, or X is 1 and Y is 0. So you can see that when X is 0 and Y is 0, we shall have 3 over 28 as the probability, the joint probability. When X is 0 and Y is 1, we shall have this probability, that is 3 out of 4, 14. When X is 1 and Y is 0, this is X is 1 and Y is 0, we shall have 9 out of 28. So applying the additive rule, we shall sum them and we shall be able to get the probability of the event A. When X and Y are continuous random variables, the joint density function is the surface lying above the xy plane. It is very important to note that the function f of xy is a joint density function of a continuous random variable x and y if 1, the joint probability is above 0 and the sum of the total probabilities with respect to x and y is equal to 1. So the probability of xy, which is an element of A, is equal to the summation of the probability over the region x and y over the region x and what? And y. For any region A in the xy what? In the xy plane. For example, a privately owned business operates a drive-in facility and a walk facility. On a randomly selected day, let x and y respectively be the proportions of the time that the drive in the walk-in facilities are in use, and suppose that the joint density function of these variables is as follows. F of xy is equal to 2 out of 5 into 2x plus 3y, and x is ranging between 1 and 0, and y is also ranging between 1 and 0, where it's 0 elsewhere. The question is, verify the condition that the sum of the joint probability distribution with respect to x and y is equal to 1. And the second question is that find the probability of the joint probability of xy such that this xy is an element of A, where A is the joint probability whose interval is between 0 and 1.5, and y is between a quarter and what? And a half. Solution. We need to integrate the joint distribution function with respect to x and what? And y over the region of negative infinity to what? To positive infinity. But we know that our interval is between 0 and what? And 1. So we shall integrate the joint distribution function 2 out of 5 into 2x plus 3y with respect to what? To x and y. For us to do that, we first need to integrate with respect to x and then with respect to what? To y. So here, if we integrate with respect to x, we get 2 out of 5 x squared divide by what? So integrating this one with respect to x, we add the power and then we divide by the new power. So if we add x to power 1 plus 1, we shall get x squared. Then if we divide by 2, this 2 will cancel. So we shall have 2x squared over what? Over 5. Plus if we integrate this one with respect to x, we shall get 3y x squared out of what? Out of 5. Hence, we can substitute for x equals to 0 and x equals to 1 in this. So when we substitute for x equals to 0 to x equals to 1, we shall get 2 out of 5 plus 6y out of what? Out of 5. Remember again, we have to integrate with respect to what? To y. So here will be equal to 2 out of 5y plus 3y squared out of what? Out of 5. So if we substitute again for y equals to 0 to y equals to 1, we shall have 2 out of 5 plus 3 out of 5, which is equal to what? Which is equal to 1. Hence, we have proved that the joint distribution 2 out of 5 into 2x plus 3y is a joint probability distribution. Secondly, we need to calculate the probability of xy, which is an element of A, where A is the event whose probability ranges for in the region x between 0 and 1 and y between a quarter and what? And a half. So we shall again integrate with respect to y and with respect to what? To x, the joint probability what? Distribution. So if we start by integrating with respect to x, we shall get 2x squared out of 5 plus 6xy out of what? 5. Then we are still remaining with integrating with respect to what? To y. But before we do the integration with respect to y, we need to substitute the interval of x between 0 and what? And a half in this expression here. So when we do that, we shall get 1 out of 10 plus 3y out of what? Out of 5. And this one is what we shall use to integrate with respect to y. So when we integrate this, we shall get y out of 10. Remember, this is like 1 out of 10 times y to power 0. So y to power 0, if we add 1 and divide by 1, we get y. and this is 3y squared out of 5 times 2, which is 10, and then we substitute for y equals to a quarter to y equals to a half, and we shall get 13 out of what? Of 160. We also need to understand other terms under random variables. One is the marginal distribution of x alone and y alone. So the marginal distribution of x is given by the sum of the joint distribution over what? Over y. Okay? Which is equal to the summation of the joint distribution for the discrete case. Whereas for the continuous case, we use the integral sign to sum over the what? Over the interval of the joint probability distribution with respect to y, which is equal to the integral from negative infinity to positive infinity of the joint distribution xy with respect to what? To x. This is the marginal distribution of y. We sum it with respect to x. Whereas the marginal distribution of x, we sum it with respect to what? To y. For the continuous case. Note that the integral is used for the continuous case, whereas the summations is used for the what? For the discrete case. In the discrete case, the values of gx and hy are just the marginal totals of the respective columns and rows when the values of f of xy are displayed in a rectangular what? Rectangular table. For example, show that the column and row totals in example above give the marginal distribution of x alone and y alone. For the random variable x, as we saw x was the number of blue balls, we can see that g of the marginal distribution of 0 is equal to 0, 0, when x is 0, y is 0, and x is 0, y is 1, and x is 0, y is 2. This one is the g of x, where x is 0. So here, these are the possible options when x is 0. So when you sum their probabilities, you shall get 5 out of 14. So when x is 1, these are the possible results when x is 1. And when you sum their individual probabilities, you'll get 15 out of 28. The table below shows the marginal distribution of x and the marginal distribution of what? Of y. So we can see when x is 0, we shall get 5 out of 14. When x is 1, we shall get 15 out of 28. And when x is 2, we shall get 3 out of what? 28. Whereas for y, when y is 0, we shall get 5 out of 28. When y is 1, we shall get 3 out of 7. And when y is 2, we shall get 1 out of what? Out of 28. Another example. Find gx and hy for the joint distribution function of the example above. So our marginal distribution of x, as we shared before, is